These are notes for 7.2, finding complex solutions of polynomial equations. We're going to start off by looking at this equation. F of x is x to the fourth minus 6x squared plus 5. It's an x to the fourth power, which means that we could potentially have 4 places where we're crossing the x-axis. And it's possible we could factor this, but let's pretend we didn't know how to factor. We would take the factors of 5 and divide by the factors of the leading coefficient, which happens to be 1. The factors of 5 are plus or minus 1, plus or minus 5. This problem you can actually factor, but again, if we didn't know how to factor, we would start maybe by trying positive 1. With synthetic division, we need a 0 placeholder for x cubed. We also need a 0 placeholder for x. So that is our setup. We're going to drop the first term, multiply, add, multiply, add, multiply, and add, and multiply again, and this time we actually get a remainder 0, which is fantastic. That means that 1 is a solution. We're going to get our list of x-intercepts going here. X equals 1. Right now this equation started off as an x to the fourth equation, which means this is technically x cubed. So what we're going to show now is we're going to take this equation, x cubed plus x squared minus 5x minus 5, and use synthetic division again. Let's try negative 1. Draw a line. This is our constant term now because that was our remainder 0. We drop down the 1, multiply, add, negative 1 times negative 5 is positive 5. And when we add, we get remainder 0, which that negative 1 is also a solution to this problem. Again, we started with x to the fourth. This was an x cubed equation. We used synthetic division again, not in the original problem, but where we were at. Now we have an x squared equation. We were at cubed, now we're 1 less. And let's look at what this looks like. X squared minus 5 equals 0. In order to solve this, we would actually just add the 5 to the other side and take the square root of both sides with a plus or minus in front of the number. And plus or minus root 5 is actually 2 solutions. So on our line here for x, our solutions are at 1, negative 1, and plus or minus root 5. If you figure out what the square root of 5 is on your calculator, you'll see it's about 2.2. So this is just a decimal. And that'll help us figure out approximately where that is. So we're going to do the same thing as we were doing before. Our degree is 4. That's an even number. It's positive leading coefficient, so it's up and up. Our y-intercept is 0, 5. And let's go ahead and graph. So we'll have positive 1, negative 1. 2.2 is going to be a little bit past 2. So let's say it's right here and right here. And because the intercepts are symmetrical, it'll look like a very symmetrical shape. The same on the right and the left side of the y-axis. Let's call this 5. We're up, up. Each of these intercepts has a multiplicity of 1. You could write it in factored form to see, but we only found one of the solutions there. So this is roughly what our graph is going to look like. Now the directions say to find all the roots. That means real, imaginary, rational, for real, or irrational. This guy here, root 5, is what we call irrational. 1 and negative 1 are rational. They are integer values, in fact, but 3/2 is a non-integer. It's still rational because it has a decimal that stops. If we go back to the square root of 5 on the calculator, you can see that the numbers keep going, and so that's what irrational is. in a easy sense. So that is the graph, and the last thing we were asked to do is to sketch it using the graphing calculator. So I've already done it for you, but there you see it on the graphing calculator, and it does look like what we came up with approximately. We're going to look at number 2 next. Number 2, let's zoom in here, is x to the 4th plus 3x cubed minus 5x squared plus x minus 6. So our list of the rational root theorem, the caboose over engine, everything divided by 1 is itself, so we're just looking at the factors of 6. 1, 2, 3 doesn't divide by 4 or 5, just 6. So we're going to start guessing and checking. If we tried 1, let's see, we have 1, 1, negative 5, 1, negative 6. We drop this number, that's 2. This is 2, that's negative 3, that's negative 2, and we can already see that's not going to work out. So we try again, maybe with a negative 1, and it's hard to kind of go back and just adjust those numbers. But if you tried negative 1, you'll see it also doesn't work. So the next number on the list is 2, and the graph can actually help you. So if we actually look at the graphing calculator here, there we go. You can see that 2 is a solution. It's where we cross the x-axis, and negative 1, negative 2, negative 3 is another solution. And so using the graph can help you, graphing calculator. But we are going to do synthetic division. We've got 1, 1, 1, negative 5, 1, negative numbers again. We're going to drop down the 1, multiply, add, multiply, add, multiply, add, and again multiply, add, and we get a remainder 0. That means 2 is a solution. So let's check that out right here. 2 is a solution. And this was an x to the 4th equation, which means this is a cubic equation. And we could see if we're able to maybe group it. I have the feeling you can because there's a 1 and a 3, but let's try synthetic division one more time. So if we go back to our graph, we can see that actually negative 1, negative 2, negative 3 should be a solution, so let's try that. We're kind of using the graphing calculator in conjunction, although, you know, it really is a guess and a check system, and sometimes it doesn't work out. It's trial and error. Multiply. When we add, we get 0. When we multiply, you get 0. You add 1 and 0, you get 1. Now we're multiplying again, and we have a 0 remainder, which again means that negative 3 is a solution. So now we were at x cubed. This says x squared. So the equation is actually x squared plus 1, which means x squared is equal to negative 1. And in fact, if we take the square root, hopefully you all remember what the square root of negative 1 is. It is I. So we have a plus or a minus I as our 2 last solutions. So again, we had a 4th power polynomial, and we end up with 1, 2, 3, 4 solutions. 2 of them are imaginary. What does that mean? That means it's not going to cross the x-axis. And this is where the graphing calculator helps us, because we honestly don't know what those imaginary solutions look like, since they are literally imaginary. And so you can see our graph is crossing at 2, crossing at negative 3, going down some amount, going back through the axis, and ending again. So we're just going to sketch it roughly the same. Our y-intercept is, y-intercept is 0, negative 6. And so we are going to plot that right here. The degree is 4. 4 is an even number. The leading coefficient is positive, so it's up on both ends. No multiplicity other than 1 for all of our solutions. And so again, looking at that graphing calculator, it went down some amount, came kind of back up here, and did this. So again, those I solutions are not on the x-axis. We don't in fact really know, what that looks like unless you use the graphing calculator. So if we didn't have the graphing calculator and we made some kind of a graph that looked like this, that would be totally fine too. And again, that's how come we have dotted lines, because we're saying this is the approximate shape. And again, we're using the graphing calculator to help us as the direction state. So I'm just going to make a note. This is not on the x-axis. All right, last problem we're going to do together, and then you're going to try one, is this guy here. It's an x cubed minus 7x plus 13x minus 7. So our list is the factors of 7 over the factors of 1. Everything divided by 1 is itself. And so what we really have here is just plus or minus 1, plus or minus 7. We're going to start with positive 1. There really is not always a good way to figure out what number to start with. Again, it's called guess and check, which means trial and error. We drop the 1, 1 multiplies to 1, we add, multiply, we add, and multiply, and lucky us, we got a 0 remainder. So if we look at this problem now, we had x cubed, this is x squared. When we do a quadratic, we do want to see if it can factor with x squared minus 6x plus 7. That is our solution, or our quadratic. We're trying to find the solutions. Where are we on the x-axis? Let's see, the factors of 7 are 1 and 7. Obviously 7 minus 1 is negative 6, but they have to either both be positive or both be negative, which adds up to 8, positive or negative. So this is actually prime, meaning we cannot factor it. And when we cannot factor, we have to use quadratic formula. So quadratic formula is the opposite of b, so b is negative 6, that's going to be positive 6, plus or minus. B squared is 6 squared, I'm just going to write 36, minus 4 times a is 1, times c, which is 7, that's the square root, all over 2 times a is 1, so we're going to write over 2. Let's see, that is 28, 36 minus 28 is 8. And what we need to do now is simplify. Square root of 8 is 4 times 2, so that's 2 root 2. 6 divides by 2, it's 3, and this 2 simplify, so it's 3 plus or minus root 2. And that's 2 solutions, one's positive, one's negative. Here's our third solution. Let's make sure that doesn't look like it's connected. And let's see what that approximately is. So on your calculator, let's just pick positive root 2. So we'll take 3 and add the square root of 2. And we get 4.4 if we round to tenths. And then we can change that to a minus root 2, and we get 1.6. We need to know what those approximations are so that we can put it on the x-axis, either to the right or to the left of 1. We need to know roughly what that is. Our y-intercept, if we go back to the problem, is 0, negative 7, and the degree is 3, positive leading coefficient, so it's up on the right, down on the left. So let's see, here's 1. Maybe here's 2, so we'll call 1.6 about right there. And then maybe 4.4 is like there. So this is 3 minus root 2. This is 3 plus root 2. And our y-intercept is down here at negative 7. it is up on this side, multiplicity of 1 for all, since we have 3 solutions, and it's power 3. It's going to be down on this side, but it has to go down through that y-intercept, which is a little strange maybe. But we go up through, and we cross the x-axis again, and there is our graph. Let's take a quick look at that on the graphing calculator. I've already plugged it in for you. There it is. So again, it's not perfect, but it's a good sketch that we have going on. If you zoomed in, you would see this does go right above the x-axis. There it is. So just a teeny tiny bit. Okay. All right, we are going to stop this video so that you can have some time to do number 4. After you finish number 4, you're going to want to just wait for the corrections. Remember last time we had a problem where we had a greatest common factor of x. You're going to want to factor that out first so that you can do your caboose over engine with the x cubed equation, and hopefully you figure out if you need to use quadratic formula or if you get an imaginary number, and then we'll go over it.